ahead and get out of PowerPoint here, and let's just take a look at how this works. And I have a simple little example. This is actually a university example, but some of you may have, that are watching this may be familiar with this from your class. It's just an operator that will do a static analysis doing these tasks. So the operator walks to this raw material location, takes 3 seconds, does some processing on a saw, and then they may walk somewhere else to L1, and then they process for 10 seconds, then they walk to L2, and so on and so on. So actually from the raw materials area, they're walking to the saw, and then they're walking to L1, and they're walking and they're walking, right? And then they have their finished task here. When we take the manual time and the walk time and the machine time, we end up with a total cycle time as shown here. And this is the walk path that you see. Okay, so let's take a look at what that would look like. If I go into Workplace Planner, and I just happen to have this loaded here, I'm going to actually calculate this in just a moment. But you can see I have this operator. I actually am doing a process and walk to. So in this case, it's another view. Instead of using M and W, where I process on one line and walk on another line, I have the opportunity to do what's called walk to and process at. So what I'm basically doing is, in this case, I'm walking to raw, and then here I'm going to saw, and I'm walking and processing. So I have a 15-second processing time, a 13-second walk time, and then I go 10-second processing time, W15, it's not 13 seconds, sorry, it's a W13, W15, we can actually look at what that total time is, 16.68. So at 15 seconds for the processing time, obviously the walk time is 1.68 seconds. And so this is another way to combine the two. It's an option that you have for specifying time. Once again, you're only specifying the fixed time on the left. The software will automatically, since I'm in a MODAPS analysis, put in the time on the right. If I want to do this as a MODAPS study, I don't have to do this as a MODAPS study. I can actually turn the MODAPS analysis off. In this case, I have a process bars or none. And if so, then we'll do a calculation and see what that looks like. So the next thing I've done is I've gone into AutoCAD and I specified these locations. Now I've already done this. So let me just go ahead and delete. I'm going to delete L2 here from the drawing. Okay, just to show you what happens if you're going into a new drawing of AutoCAD. The one thing that's important with your AutoCAD drawing is that it's drawn to scale. And so let me just talk a little bit about AutoCAD. So if I go into the units command in AutoCAD, and just so that we're really clear here, I'm going to go ahead and type in units. Okay, sorry, units. And I can see that I'm in architectural units. In this case, I actually want to be in engineering units. I strongly recommend that for the American organizations where the layout drawings are typically feet and inches. If you are a international organization, non-American based group, chances are pretty good you're going to want to stay into decimal, okay? Those are your two choices. I probably wouldn't recommend architectural. And of course, if I'm in decimal, I'll probably use millimeters as my base unit. If I'm in engineering, I want inches to be my base unit, okay? The other thing I'm going to want to do is then make sure that when my drawing is drawn, that things are to scale. So that if I do a distance, I'm just going to do a rough distance from here to here. You can see that's about 3.5 feet. That's about right for the size of this rack. So my distances are correct. So now that I have an AutoCAD drawing drawn to scale, my units are specified correctly. The next thing I'm going to want to do is make sure in my settings that the software is also seeing that I'm in the proper units. You need to make sure that Workplace Planner's units matches the drawing. Now, if this drawing was drawn engineering or architectural, Workplace Planner should be able to figure it out pretty quickly what's going on. And it did. Output units are feet, input base drawing units are inches, we're in good shape. If the drawing units in AutoCAD are decimal, then it really doesn't know what the base unit is. Is it a millimeter, is it a meter, or is it even inches? And so make sure that it'll probably default to meters on the output and millimeters on the input if your AutoCAD drawing is in decimal units. So just be careful of your units. Okay, the next thing we're going to do is we're going to do a calculation. We file open. I've grabbed that spreadsheet file that we're looking at right here. And in this case, I'm not going to do a MODAP study. I'm just going to use those as times. That's fine. Those will go, those W's will go away here in just a moment. I'm in stationary analysis, which means the product is not moving. That'll be the default. And I just literally just do a calculation. It says some locations are missing. Would you like to add them? Sure. It wants to know where I want L2 to be. I'll put L2 right over here. The software added L2. So notice there are some polylines in the drawing. I'm going to go ahead and delete those. And there's my L2. You can see the software updated, and there's my walk path for the operator. The software has gone ahead and entered the distances for each of those, and these are all controllable. I can go in, you can see I have a number of tabs here in Workplace Planner. I can go into the paths and I can change my arrow sizes. I could even get rid of arrows. If I don't want arrows, I get rid of arrows and calculate. You can see they go away. I can go to paths and I can add my arrows back. I can change the dimensions of the arrows as I wish to. I can also add path labels. I can delete the path labels. I can update, add the path labels, however I want. I can make the labels any size I want. All pretty easy stuff. The other thing I can do in the drawing is specify information about the operators. By default, I've got an operator working at 4.17 feet per second unloaded, loaded 3.33. I can change any of that. This editor is a little simplified. So if I do change something like change that to 5 feet per second, I just make sure I need to hit the update, and you can see it updated right up in here, and that'll get shown up in the drawing. The other thing I can do is specify what AutoCAD block I want to use. There's a number of blocks in this drawing for the car or the machine or whatever this resource is. Typically, I look at it as an operator that I want to use. And I happen to have a symbol that's included with the Workplace Planner called PP_person that you can use for your symbol of your operator. And I'll show you why that might be important here in just a moment. If you ever need to go to AutoCAD to do something, you just click go to AutoCAD, you click in the drawing to activate your mouse. You can see I can then window around here as I wish to, and then come back and return to the Workplace Planner interface. So I can jump back and forth pretty easily. I can also change where I want the operator to start at, what color I want to use for the operator's walk path. In this case, I'm using yellow. So there's a lot of different values that I can specify. So the locations, by the way, as you notice, the software prompted me for the location. It read the locations from the drawing. These location text labels are stored on a certain layer, and that particular layer that they're stored on is specified in this particular area of the software. You can see that location text layers PP_locations, which is the default. But you can change that and use a different one if you wish. The path layers are automatically created by the software, and each operator has its own path layer. Okay, as I mentioned, I did a calculation. The software generated this walk path line. It calculated those walk distances. It updated the distances you see here. It updated the processing times you see off on the right. And just calculate that one more time just so you can see how that works. And you can see over here that the total cycle time for the operator is 160 seconds. The distance traveling 66 feet. They're doing 23% walking. They're doing 77% non-value added time. That's because the lean percents on these are all 0 right at the moment. But if I said this processing time is actually value added, I could put 100 on there and update that row. If I said, and you can see I have different symbols. So I could say, well, that actually is an operation time. So I'm actually processing that and update that, okay? I could say, you know what, this particular task is an inspection task. And I'm going to say that I'm going to consider that to be /100, 100% non-value added, but necessary. I may choose to do that. This one, I could go ahead and make an operation task. I could say that that's 100% value added, and so on and so on. And then when I calculate that, you can see that the software is going ahead and updating these values here. Since I don't have two operators, I don't have any interdependency between them. There's no internal delay. There's no external delay. When I look at the lean tab, you can see that now the breakdown of those tasks are there. And if I right click, I can copy the data that generated this bar chart or an image of the bar chart. I can copy that and paste it into applications like Word and Excel. The other thing I can do is I can do an animation. So I'm in AutoCAD, and what the software is going to do is move that little block around. In this case, I'm just moving this little circle, processing at the tasks as we go through and creating a trace file, okay? Once again, if I go to the operators. Once I get PP person, default circle, I can actually check a person block, update that. And now when I go to animation, you can see that my actual person is walking around in the drawing. And that's actually a 3D person. This isn't a 3D drawing, but if it was, we would see that. Okay, so you can kind of get an idea on how that's working. So we've got the lean chart, we've got some animation, we've got our cycle time calculations. The processing times could be specified in predetermined languages. So we would have the parsing of our cycle times. We also have a report. I'm going to go ahead and get an image of the current display and generate a report. And you can see there's a report showing the type of process where I specified it, the step in the Excel file that I'm using, the location where the work's being processed at. I could have entered a description of the work being performed. I didn't do that in this particular case. The distances that were extracted from the drawing, the processing time, the walking time, and the total cycle time, as well as a picture of the layout. So this is a nice report that just gives you kind of a station summary report for your lean analysis. Of course, you know, as I mentioned, I can change the layout any way I want. Obviously, I could have put L2 anywhere. I could have gone into AutoCAD and I could say, you know, what happens if the saw was located over here? Right? No problem. You go back, you recalculate, your diagram's updated, your cycle time's updated, your reports are updated, and your animation is updated. Easy peasy. Okay, so that's one operator. What happens if we have multiple operators? Well, no problem. I've got a simple little example here. In fact, if I go to, I'll show you an example in the images here. What if I go to a dual operator? We have worker 1 and worker 2. They have 2 different cycles. I've allocated the work accordingly. So in that case, that's what I've done here. I did this task, operator 1, operator 1, operator 1. There's operator 2, operator 2, operator 2, operator 2, operator 1, operator 1. Now, the key thing is that the operators right now, there's no synchronization. There's no type S event here. What that means is that operator 1 is going to do his work in parallel with operator 2 doing her work, okay? So the 2 operators are just working in parallel. There's no blocking. It doesn't really matter the order now between operator 1 and operator 2. As long as the operator 1 tasks are done in sequence and the operator 2 tasks are specified in the spreadsheet in sequence, everything is good. The only time it matters where one comes above another is when we have interdependency or synchronization events, right? Well, we don't have one here. It's just a simple analysis. Let's draw this. So I've got my spreadsheet. I loaded it. I hit calc. All the same locations are specified. There's my work. Of course, I'm in AutoCAD. I can say, you know what? That's kind of silly. Let's bring this all over here and let's rerun that calculation again. Now, in this particular case, there's no internal delay. There's no external delay. Once again, I didn't specify my value added, so it's all non-value added. We're walking at this point, and you can see my cycle time specified, 81 seconds for one, 81 seconds for another. They're all pretty close. I could choose to say, you know, one of these people is going to have to work longer than the other person. Notice what happens if this task was 30 seconds instead of 20 seconds. You can see now, while the walking didn't change, we certainly have a situation where one operator is getting done before another. Now, we could say that each operator is its own cycle independent, but we all know better. If this is a repeated cycle, operator 1 is going to be waiting for operator 2 to finish before they can repeat their cycles. So I'm going to pick longest here, and now you can see I have a delay. Okay, and I could specify a takt time. I could say, you know what, the actual takt time of this process is 100. And in this particular case, they're now both waiting. Okay, so, and I can animate this and show, animate that and show the operators moving. Now I did specify a symbol for the second operator. Let's get it easy to do. And you can see the operators are performing their work. Okay, what about interdependence? Well, let's take a look at it. Now it matters. Let's say that we get down to a point where operator 1 does this task, this task, this task, while operator 2 is doing this task, and this task, okay? 3 tasks for operator 2, 3 tasks for operator 1. Now, for operator 2 to do their 4th task, for operator 1 to do their 4th task, these 2 have to be done. They can't start these tasks, even though they aren't at the same time, that's okay. They can't start either of these 2 tasks. Operator 2's 20-second task at VM2 and operator 1's 15-second task at G. These cannot be started until they are both available. So ahead of operator 2, I'm going to insert a row. Okay, I'm going to make that a synchronization event. I'm going to specify that the second operator is operator 1. And I'm going to update. Okay, now operator 1 does these 3 things, operator 2 does those 3 things. They both have to be available. Then operator 2 does this while operator 1 does that. And then operator 1 goes and does this other task, and they're all good. Let's calculate that. I didn't change the layout, so the drawing's not going to update, but you can see the cycle times have updated considerably, okay? In fact, now I'm beyond my cycle time, okay? So now we're in creating this interdependency event. Let's go ahead and animate that. We can see. So what are we going to be looking for? Well, obviously, the only task operator 1 does after the synchronization event is here at G. And the only task operator 2 does after the synchronization event is VM2. So neither operator should go down to G or VM2 until they are both available, which means one of these operators, as we can see here with the internal delay, likely operator 1, is going to be waiting on the other operator prior to that synchronization event. Let's watch it. So this operator is going to go to VM11 and wait until they're both available. Neither one of them is leaving this location. Once they are both available, now they can take off and go to their next location and do their work, whatever that work happens to be. So you can see how synchronizations are, events are handled.